34 million people are hospitalized each year in the United States alone. Of that 34 million, up to 35% are impacted by a condition called hyponatremia. Patients in the intensive care unit and post-operative patients are most susceptible to developing this condition.
Hyponatremia is defined as low sodium in the blood. This can cause fatigue, convulsions, or seizures, low blood pressure, and even a loss of consciousness. The accuracy and efficiency of correction detection systems and processes are a concern, as they require frequent collections of blood samples from patients that take at least 20 minutes to provide an accurate result of blood sodium level.
Therefore, Brunei Fluid Control Solutions recognized the need for an automated system that could provide healthcare workers with an accurate diagnostic feedback in order to improve patient care. By partnering with Brunei, we designed a real-time, closed-loop diagnostic system for inpatient treatments at hospitals that is compatible with current IV delivery pump systems.
SALTBand, which stands for Sodium Assessment and Level Targeting Band, is a wearable biosensor capable of detecting the sodium, potassium, and chloride ions in a patient's blood. From these relative concentrations, the device will be able to determine if the patient is experiencing hyponatremia and use a controller to automatically infuse saline and bring the patient's blood sodium levels back to the normal range.
SALTBand works by connecting to the patient's blood catheter and pumping a sample of blood into the microfluidic chip, where it will mix with anticoagulation agents to prevent protein buildup. From there, the blood sample is pumped through the chip as 3 ion-selective electrodes, known as ISEs, detect the concentration of sodium, potassium, and chloride. The ISEs will output a corresponding voltage that is then read by the custom PCB and electronics housed in the device. These values are then used to determine whether the patient is experiencing hyponatremia and what appropriate treatment should be administered.
This information is then used to pump a corresponding amount of saline from an IV pump into the bloodstream. SALTBand will then continue to monitor the patient's condition and adjust treatment as the patient's relative sodium levels increase or decrease.
To accurately demonstrate the design concept within the project's timeline and budget, we constructed a representative macro system of the closed-loop, real-time detection and delivery system. This macro system utilizes a composite sodium ion selective electrode, which produces a voltage based on the difference between sodium concentration in the blood and the reference fluid inside the electrode. This minuscule voltage is measured by a high impedance voltmeter that continuously transmits the data to a Raspberry Pi 5. The Raspberry Pi 5 displays the data on a screen.
A drop in sodium concentration is detected as shown in the video. When a healthcare professional activates the Implement Correction button on the graphical user interface, the system employs algorithms grounded in current healthcare best practices and standards to automatically adjust the patient's sodium levels to normal with saline infusion using peristaltic pumps.
By combining our interdisciplinary skills, we were able to design and build a custom representative of SALTBand that successfully performs as the first closed-loop system with real-time sodium detection capabilities that corresponds to a saline delivery process. We invite you to stop by our booth at the Capstone Expo to learn more about our project.